And with this, we start off really to say that could I convert, in a general sense, not making these specific assumptions, could I convert a first order logic into a zeroth order logic? Of course, I won't be teaching you logic again. It's not a fundamentally different set of algorithms, it's the same resolution, forward chaining, backward chaining. So, can I convert a zeroth or first order logic into a zeroth order logic? And the answer is yes. So, first let's solve the first problem, which is that there are two new things that I introduced, the quantifiers. And because I introduced two quantifiers, let us see how do we deal with the quantifiers if they happen to come in your language. So let's first go with the universal quantifier, which is for all. And for all is easy. You could substitute each and every object in for all, and because I can substitute each and every object in for all, that's exactly what I do. So I had a rule which said bad marks ai comma r as a variable for all r, and studies ai comma r implies, in fact, let's do it more. I generalize it to the course C. Honest, all these are variables for all R and C. So now I can replace it with everything. So I apply the substitution of C is equal to AI and R is equal to R1 in this rule. So let this rule be alpha and what do I get? Now you can get the whole thing back by this substitution. Bad marks. I could choose any C, I could choose any R. Let's choose all permutation and combination of them. Now they are not underlined, they are not variables. It's this exercise is called as the universal instantiation. So it's a universal instantiation. In general, it's written as if I have for all x the statement alpha, it's a statement, it's a rule, it's a statement, holds, then again it's not a divided by, given this, then this, given this, resolved to this, I can get a substitution of V by all possible grounds. So G is what is called as a ground statement. So here G is what is called as a ground, which means it's variable free or it doesn't have any for all there exists. Now remember, when you do that, I could replace in general R with R1, R2, R100, best friend, R, best friend of best friend R1, and so on. So the number of universal instantiations are infinite. Even though they are finite because they are finite ground objects, they are infinite because the number of times I can apply this is infinity. So already my proof doesn't hold good. I haven't converted a first order logic into zeroth order logic, or I have done a conversion of first order logic into a zeroth order logic with infinite sentences, and it's unsolvable because of these functions. So the other one is, of course, what is existential quantifier that exists. So let's do that for let's do it for that as well. So if there is something like that exists x and alpha, then I can substitute it x. Oops, this was x with a specific constant. So the specific constant can be anything, let us say z. So here this is a constant, this is what is a variable. So I replace it with a specific constant in the sentence alpha. And this has a special term. It's called as a scolomization, where you replace x with a new constant z. The constraint is that z should not have occurred anywhere else. So it's like it's good to take in new constants, but I did not take x, so I had to take a unique variable name. So I actually looked around, and a variable which had never been taken, I actually took that one. So you could take anything, it has to be a new variable name. So let me give you an example because I just forgot. So we also have a rule that there exists a R such that not honest ai comma r is a variable. So I say let r is equal to the person who is not honest is r question mark. So it's a new roll number, it's a new student. So I replace this there exists r with not honest. Now I know who's exactly not honest. It's r question mark. Now whether r question mark is equal to r1 or r2 or r3 or r4, I let my ground rules try to prove it. Whom does it really point to? I let my ground rules point out to that. And once when I get that, I know exactly who is dishonest. But then the one thing which is sure is their exists has been removed. The problem really is that they are infinite objects because of this best friend of best friend of best friend of best friend of best friend. This little problem around over here. Now, luckily, I can solve this thing up and I can convert this into finite objects. So, what do I do is I first try to get a zeroth order logic system with only relations, objects, and propositions. Till level 1. So I only apply 1. I take R1, I take R2, I only take best friend R1. I do not take best friend R1, that's level 2. So I get finite objects, I let all my zeroth order logic theorems now applicable, there is no for all, there is no there exists. I let all of them decide true, false, whatever. And once I get that, I'll do my theorem proving. If, however, I cannot get a result, then I'll try level 2. If this does not work, then you try level 2, where now you take best friend R1, Along with that, you can also take best friend R1, and similarly for the others. So, and then you go level 3, then you go level 4. So that's iterative deepening. It's complete. However, it's only complete as long as you have a solution. If you don't have a solution, it goes on infinitely. And because it goes on infinitely, because there's no solution, it's actually semi-decidable. That means there is no way the algorithm could say no. If something is true, it will prove it, it will give you true. But if something is no, if something is false, if something cannot be determined, then it absolutely cannot work. Or it goes on to infinite parts. It keeps on adding best friend. Now, best friend is just one example. It could be father, mother, edge, whatever. It goes on into an infinite steps to try to prove this thing up. So with this background, when we've almost done like conversion into zeroth order logic, let's go upon to the same root, and of course I'll not teach you the zeroth order logic algorithms. Again, I'll just tell you how are they equivalent to the first order logic. So let's go to the modus where we started the zeroth order logic, Ponens. It's the zeroth order logic modus Ponens, which is generalized into a first order logic, and therefore let us really do that. So I have a rule in first order logic for all RC. I have bad marks of the rule number R into code C. I think I wrote it the other way around. And studies RC and student R and goals C implies honest RC. Now I apply a substitution throughout each one of these as C substituted by AI and R substituted by the one whom we knew had bad marks, R1. So I apply the substitution throughout. So in general, let this be P1, let this be P2, let this be P3, and let this be P4. So, and let this be Q. So in general, any rule is P1 and P2 and implies Q. In this specific case, I have P1, P2, P3, P4 as bad marks, CR, studies. Oops, it also should have been the same. So CR, student R, and goals C. And after substitution, I get something which is specific. So apply the substitution over here. That's a substitution that I'll apply in throughout over here, and I'll get in new things. So C is substituted by AI. Again, it's not divided by. It's this substituted by. The slash is a fancy way to say that. AI. Oops. So bad marks. P2 dash is studies. P3 dash is student R1 and P4 dash is goals AI. Remember, the substitution will remain as it is the same. You cannot substitute it with AI at one place and robotics at the other. Now, these were the antecedent. The consequent is honest RC And I'll apply the same substitution over here. Q dash will become honest R1 comma A. Oops. Let's do it CR. So this also becomes C and R. And all of these are given in the data set. So this is already given in the data set. That's how I apply my substitution, things which are already given. This is also given in the data set. This is given in the knowledge base. Knowledge base. This is also given in the knowledge base, and this is also given in the knowledge base. And because all of these are given in the, oops, this is not given in the knowledge base. So because these are already given in my knowledge base, I could apply D substitution in the rule and get this as the results with respect to this as a specific substitution, which gives me this as the specific new knowledge. And therefore, let me write it down over here, whatever I have written in the specific format first. So I had in my knowledge base bad marks AIR1. This was in my knowledge base. I had studies AI comma R1. This was in my knowledge base. I had student R1. This was in my knowledge base. I had goals AI. This was also in my knowledge base. And in my knowledge base, because my game, my rules, I also had the general rule, which is bad marks C comma R, and write down this complete rule implies honest CR. Given this, I can make in the specific substitutions noted here on this specific substitution, and I can get the consequent, which will be the substitution C by AI, which is what I use to get all the premises, R as R1, on my consequent, which is a honest C comma R. So this indirectly will give me, if I applied C is equal to AI and R is equal to R1. This is what is the generalized modus ponens. And it's pretty obvious that you had a rule which is valid for all C and R. So you specifically substitute those C and those R if one is possible. So you had a generalized rule, you substitute specific C, specific R such that the premise becomes true. And because the premise becomes true, the consequent will follow. Now the problem is the consequent is not ground, but you have to make it ground by this exactly the same substitution as you get there. In general, it's called as, if I have given P1 dash, P2 dash, P3 dash, Pn dash, in my knowledge base, and I am given a general rule P1 and P2 and P3 and Pn implies Q, then I can resolve under the same substitution theta that I use. So P1 dash is basically obtained from substitution of theta into P1. And this is what is the generalized modus ponens. And that's what I obtain from it. The specific operation is what is also called as lifting. So a zeroth order, you call it as a modus ponens. So you lifted a zeroth order logic into a first order logic. You took a lift and you lifted it up. So this is in general what is called as a lifting of something which is zeroth order into something which is of the first order.